Okay, let's take a look at solving this inequality. We want to look at some practice exercises. And what I want to do when I solve the inequality is graph the solution set and also write it in set builder and interval notation. So my first inequality is x minus 4 greater than or x minus 1 greater than or equal to 4. So solving the inequality in this case means getting the x alone on one side of the inequality symbol. And I recommend always getting the x on the left side of the inequality symbol. That's not absolutely required. It could be on the right, but students have a hard time interpreting it correctly if that variable is on the right side of the inequality symbol. So I recommend always getting it on the left. If you don't have any problem, can understand when the variable is on the right side of the inequality, no problem. But I just want to warn you that many students do have trouble interpreting that correctly. All right, so I'm going to add 1 to both sides of the inequality. That's our addition property of inequality. And I get x is greater than or equal to 5. Okay, so I want to graph this solution set. That's one of the things I was asked to do. So I start off with a number line. So this is going to be my graph. And I need to show 5 is called an endpoint. I need to make sure I show that on the graph. I can show other numbers on the graph, but I have to show that one. So say, for instance, if I want to show 0, that's fine. I just need to make sure 0 is to the left of 5 because it's smaller than 5. So any other numbers you show have to be in their correct position. And then I want to shade everything to the right of 5, because any number that's greater than 5 is to the right of 5. And that would be what my graph would look like of my solution set. As an interval, when 5 is included, remember this equal to in the inequality x greater than or equal to 5 means 5 is included. So on a graph, I show that with a solid circle. On an interval, I show that with a square bracket beside the endpoint. You just want to make sure that your bracket is very clear, that it's a bracket and not a parenthesis. Indefinite movement to the right in interval notation is shown using the right-sided positive infinity symbol. So this is my interval notation. And then we want to use set builder notation. So I use a brace, which represents the set of all x such that x is bigger than or equal to 5. So that's my set builder notation. All right, so 3 different ways to show our solution set: a number line graph, interval notation, and set builder notation. These all 3 represent the same set of numbers, 5 and all the numbers to the right of 5. All right, here I have an inequality where I want to also simplify this or solve this. And I'm going to recopy it just so things are a little larger. And I'm going to do that by subtracting 7 from both sides. And also I'm going to subtract 2x from both sides of this inequality. When I say both sides, I mean both sides of the inequality symbol. So 7 minus 7 is 0, and so is 2x minus 2x. So I'm left with 3x minus 2x, which is x, greater than negative 5 minus 7, which is negative 12. So I want to draw a number line for this, an interval, and set builder notation. So here's my graph. I can show as many numbers as I would like, but I am required to show the endpoint of negative 12. And that it's not included, so you want to be careful, that's not included in my solution set, since I don't have an equals to here. That's why it's not included. Alright, so above the 12, I have an open circle. I want to make sure it's clear that that's open. And then I'm going to shade everything, shade to the right. And there it is. That's my number line graph. Alright, I want to show interval. Okay, so this is my graph. The negative 12 is not included. Open circle above it for that reason. And my movement is indefinitely to the right of negative 12. Since negative 12 is not included, when I go to write it as an interval, I put a parenthesis beside negative 12. Indefinite movement to the right is illustrated with an infinity. And this is interval notation. Okay, and then set builder notation, I use braces, the set of all x such that x is greater than negative 12. So that's my set builder notation. Three different ways to show or illustrate the same set of numbers. Okay, so here I want to solve this inequality, and this is a compound inequality where negative 4 has to be less than 1 minus 3x, and 1 minus 3x has to be less than negative 1. So that's a compound inequality. Whenever I'm solving this type of inequality, my goal is to get x alone in the middle of the inequality. So I'm going to do that, move toward achieving that by subtracting 1 from all segments of the inequality. So I'm left with negative 5 less than negative 3x is less than negative 2. And in order to get the x alone in the middle, I'm going to have to divide by negative 3, whenever I divide by a negative, I always change the direction of the inequalities symbols at the moment that I divide by that negative. So we wind up with 5/3 greater than x greater than 2/3. All right, now whenever I write this type of inequality symbol or inequality, the smaller number should always be on the left, just like it would be on the number line. The larger number should be on the right. And notice that the point of this inequality symbol is toward 2/3. That's still true as I switch the order. The point here for this inequality symbol is toward the x. Well, notice how that's true here. So those two inequalities say the same thing. Now let's show it as a graph. So there's my number line. And I want to show that 2/3 is not included. So I put an open circle above 2/3 and 5/3 because the inequality has no equals to symbols on it, just less than. So these endpoints are not included. And I simply shade everything in between. Okay, and we have shown this as a graph. Let's now show it as an interval. Well, neither endpoint is included, so I have two parentheses. It kind of looks like an ordered pair, but it actually is different from an ordered pair. It's representing all the numbers in between these two numbers. And then using set builder notation, the set of all x such that 2/3 is less than x, which is less than 5/3. And that's how we would solve that compound inequality. Now here, and how we would represent the solution set in the three ways we were told to represent it. Here, I want to distribute. I want to remove these parentheses. So 5x minus 2x, and I'm subtracting a negative 5. So 5x minus 2x is 3x, and minus a negative 5 is plus 5. And that's greater than or equal to 3x plus 7. Now let's subtract 3x from both sides. And we see we get 5 is greater than or equal to 7. And that's a false statement. 5 is not greater than 7, nor is 5 equal to 7. So when the variable drops out and a false inequality results, there are no solutions. This will never be true. And I don't need to graph or try to write this as an interval. If the solution set is the solution set, you can either write a pair of empty braces, as I have done, or the null set notation, which is 0 with a slash. I prefer this because it very clearly shows we have no solutions to put in here. All right, let's look at this inequality, and again, let's distribute 3x minus 3 plus 2x is less than 2 plus 5x plus 5. All right, let's combine like terms. So I get 5x minus 3 is less than 7 plus 5x. And then I'm going to subtract 5x from both sides. Only to see that I'm left with an inequality that has no variables in it. Is negative 3 less than 7? And it is. So this is true. This is a true statement. So that basically means negative 3 really is smaller than 7, that this solution set is the set of all x such that x is a real number. So I can use, if I replace all three of the x's in the original inequality with any real number, so they have to be the same real numbers. Like if I'm going to use x equal to 6, all three of these appearances of x have to be replaced with 6. And then when I go to write this as a graph, I show the number line. I don't need to show any numbers on the graph when it is my solution. So we can move anywhere we want on the number line, and we're at an x that's in the domain of this function. And then as an interval, we write the interval from negative infinity to infinity. And so that's how we would solve that one. Okay, so that's how we would solve this situation where the variable drops out of our inequality and the statement that results is true. The solution set consists of all real numbers. And here's how I represent the set of all real numbers. All right, and we're going to stop there with this and hope that this was helpful.